This is Professor Rogers. This presentation is the first video in a two-part series on univariate descriptive statistics in the analysis of numeric variables. Across the two videos, we look at how to get these statistics in SPSS and PSPP. We take a look at two different types of numeric descriptive statistics, arithmetic and positional. We close the second video with how to report descriptive statistics in APA-style tables. Arithmetic measures are determined by using the basic arithmetic operations: addition, subtraction, multiplication, and division. Positional measures are determined by where the number sits in the distribution. Each type of measure has its own measure of central tendency and measure of dispersion. As an example, we look at state-level data in specifically three variables: the violent crime rate, the imprisonment rate, and the poverty rate. Follow the path Analyze Descriptive Statistics. Three different commands can be used for numeric descriptive statistics: frequencies, descriptive, and explore. Frequencies is the best option for arithmetic measures. This command is the same frequencies command used to create a frequency table. We need to alter the options for the command to meet our needs for the description of numeric variables. First, we select our variables. The right box titled Variables is where we put the variables to analyze. The three variables were originally on the list on the left. They were highlighted, then moved to the right box using the toggle in the middle. Second, we turn off the frequency tables option. In SPSS, we remove the check from the box in the lower left-hand corner. In PSPP, the process for turning off a frequency table is more complicated. The large box on the left is the command dialog box in PSPP. Go to the bottom, then click on the option for frequency tables, which is highlighted here by the red box. This action opens a second dialog box that allows us to turn off the tables. The second box is shown here on the right. Go to the Display Frequencies Tables section and click on Never. Third, select the statistics we want. This selection happens differently in SPSS and PSPP. In SPSS, in the Frequencies command dialog box, click on the Statistics option box in the upper right-hand corner. This action opens a second dialog box, which we see on the right. We need to click on the boxes of the variables we want. Check on all the statistics for three boxes: central tendency, dispersion, and distribution. In the percentile variables section of the box, check quartiles only. This result will give us more than just arithmetic measures. It will also contain positional measures. This combination is okay. Both sets of statistics are often run together. We will discuss only the arithmetic measures in this presentation. In PSPP, select all the statistics in the Statistics box on the Frequency command dialog box. The result gives all the same statistics as produced in SPSS except the quartiles. As our final step, we create a histogram, which gives us a visual picture of the distribution. In SPSS, we click on the Chart option on the command dialog box, here shown on the left. This action opens the dialog box shown on the right. Select Histogram as the chart type, and also check the box to show the normal curve. PSPP also has a Chart option, which opens the dialog box on the right. Check Draw Histogram and Superimpose Normal Curve. The output we get has all the selected statistics. Here is the SPSS output, and I have highlighted all the statistics that are arithmetic measures. We will go through 5 of them: n, sum, mean, variance, and standard deviation. N stands for number. It is the count of the number of observations in the dataset. The n is not technically an arithmetic measure, but we need it to calculate some of the other arithmetic measures. SPSS gives a count of both non-missing and missing data. There are 51 non-missing observations for violent crime rate and 51 for poverty rate, but only 50 for imprisonment rate. I know from exploring the data that the one missing observation for imprisonment rate is the District of Columbia. Add all the values together and we get the sum. On the output, the sum is highlighted. On the right is how the sum is calculated. X subscript I means the ith value of the variable. There are a total of 51 possible i's, one for each observation. The squiggly thing is the Greek letter sigma capitalized. In mathematical notation, sigma stands for sum. Thus, the equation says we should add the values of all the 51 observations together, or 50 in the case of imprisonment rate. Just a comment about the sum. The sum is not always a useful number, and the variables that we have here are examples of this. Let's take violent crime rate. If our variables were the number of violent crimes, the number would be useful. However, in this case, the number of violent crimes has been standardized to form a population rate. So the number that we see, 18,836, has no intrinsic meaning and is not a useful description of the data. Nonetheless, we still need the sum because of its use in other calculations. The arithmetic measure of central tendency is the mean, or what could be called the arithmetic mean, or more commonly what we call the average. The mean is highlighted here on the output. The typical state has a mean violent crime rate of 369, an imprisonment rate of 404, and a poverty rate around 15%. The exact number that one would report in a table would be rounded. The values shown here are too precise. On the right is the formula for the mean. The numerator of the mean is the sum. To get the mean, we divide the sum by the n. The measures of dispersion for arithmetic measures are the standard deviation and variance. These two measures are related. The standard deviation is how far the typical point is from the mean. The variance is the square of the standard deviation. Many complex statistics are built on the n, the mean, and the standard deviation, so we need to take some time to understand the standard deviation in detail. We will look at the equation and also work through its calculation using a couple of data points. The standard deviation is the measure of dispersion associated with the mean and refers to the average distance of each point in the distribution from the mean. It is symbolized by the Greek letter sigma or the English letter s. On the right side of this slide, we see the full formula for the standard deviation. Let me break it down into steps. In the first step, we take the difference of every point from the mean of the distribution, then square it. Squaring it might seem strange, but this approach to distance is commonly used in Euclidean geometry. For example, you've probably seen the squaring of a difference to get a distance before with the Pythagorean theorem, which we all learned to use to calculate the sides of a triangle. Here I do this calculation on the violent crime rates for two states, California and Ohio. The x column is the violent crime rate for each state. The x minus x bar column is the distance between the point and the mean. The number is positive if the state's value is greater than the mean, and negative if the state's number is less than the mean. In the final column, we square the distances, which turns each number positive. Then we add up the squared distances. Notice the Greek letter sigma, which indicates sum. With our example, I did this calculation for all 50 states in the District of Columbia. Below the table is the sum of the squared distances for all 51 observations. Divide this total by n minus 1. This spreads the distance over the number of points in the distribution. One might think that the denominator should be n, but we subtract 1 to account for a degree of freedom. There are n points, and I have already used up 1 degree of freedom by identifying one fixed point, the mean. So the remaining number of points is n minus 1. There is no distance between the mean and itself, so the distances are spread over the remaining points. This number is also called the variance. In SPSS, the variance number is included in the output. Here the variance is calculated for the example. For the final step, take the square root, which undoes the squaring earlier. This gives us the standard deviation. Here the standard deviation is calculated in the example. You might be wondering why we are not looking at frequency tables. Frequency tables do not handle numeric data well because we usually get only 1 or 2 observations per value. Here is the frequency table for our example data. We can barely squish it onto the page. The table gets larger and larger as we increase the size of our data set, and some software programs won't even run frequency tables when they exceed a certain size. In short, the frequency table is not a useful descriptive statistic for numeric data. The final piece of output we look at in this presentation is a histogram. A histogram is a graphical summary of the shape of the distribution. The histogram itself is the vertical boxes. The distribution is separated from its lowest to highest values into units of equal widths, which are called bins. The frequency of each bin is the height of a gold-colored vertical bar. The frequency can be expressed as a count or a percent of the total distribution. Either way, the graph looks the same. The contribution of each point in the data is the same in the histogram, making it an area chart with the total area of the chart accounted for in all the gold-colored bars. The curved line added to the chart is the normal distribution for a group of numbers having the mean and standard deviation of the violent crime rate data. The usefulness of this line is discussed in the video on the normal distribution. The output includes several other statistics that are arithmetic. I discussed their meaning in the presentation on the normal distribution. The first part of this 2-video presentation on descriptive statistics for numeric variables ends here. We looked specifically at arithmetic measures. We learned how to obtain them using the frequencies command in SPSS and PSPP, and how to represent them graphically using a histogram. The presentation continues in the second video with positional measures and how to put descriptive statistics in an APA-style table.